interesting question here, a projectile question. And all the question gives us is very little actually. So we know there's some projectile which is fired. They don't give us the velocity, but all that the question does say is that the sy, so the max distance in the s, is equal to the max range. So the sx is equal to the sy. That's absolutely all the question gives us. And they ask us to find this value of the angle, which we also will call alpha. So all the question says is that sy is equal to sx. Find alpha. How are we going to do this? We are not given the velocity, but we can just say that the projectile was shot at some velocity u. What we're going to want to do is resolve it into horizontal and vertical components. So this is very simple trig. Here we have the opposite over the hypotenuse. Hypotenuse is u, so it's u sine alpha. And the horizontal component is u cos alpha. Now, as in any projectile question, I'm going to start filling out my table. My I and j table, or my x and y, whatever you want to call it. I'm going to call it I and j. So here we have the horizontal and the vertical components. So the u vast, we're going to fill out all the values for u vast. U. So the u in the horizontal is u cos alpha, as we resolved there. And the thing is, what you need to know with all projectile questions is in the horizontal direction, the acceleration is always 0. There's nothing slowing it down and there's nothing making it faster. So the acceleration is 0. Because the acceleration being 0, the initial velocity is equal to the final velocity. So the final velocity is also u cos alpha. Now, we'll move on to the vertical component. As we can see, it's u sine alpha. And the thing is, in the vertical direction projectiles, there is a deceleration. It eventually goes down to 0, so when we get to our max, where sy is, the velocity in the y direction is equal to 0. So since it's slowing down to 0, there must be some deceleration, and it's minus g. G is a constant, it's 9.8, so minus 9.8, but I'll just write g for simplicity. And at this maximum height, it's some value, we'll call it s. So we don't know it, we're trying to figure that out. We're trying to make two equations that'll cancel each other out, so we'll call that s. Projectiles are also symmetrical, so here, sy, this is exactly s, half of sx. So where this is, in terms of sx, is exactly half. So in the distance in the horizontal direction is only half of s. So that same s is just halved. I think this is enough values to start filling out the t. We can't find the t because nothing is given to us. But using these values, I think we can figure out t in terms of these values. What I always do with every projectile question, or in general, I always write out my 3 equations of motion because I think it'll help us find out which one is useful for us. Now, using these, I'm going to use the first one first to try and find an expression for t to fill out both of these in terms of the other variables. So let's just use the first one. So v is equal to 0. We'll talk about it in the vertical direction. So 0 is equal to sine of alpha, u sine of alpha, sorry. And that's equal to, plus at, so minus gt. When this goes to the other side, we can get an expression for t. So u sine of alpha is going to go to the other side, and we're going to divide by minus g. And because there's 2 minuses, it's just going to turn into a positive, because a minus divided by a minus is a plus. So we can just get rid of the signs here. So now we have an expression for t in terms of the other variable. We can fill that out. This should be very useful for us. And that's over t. And like I said, the projectile is symmetrical. So at this point where the t is equal to, that should be g, u sine alpha g, we know that the whole thing would equal to half of it. But we're not interested in the whole thing, so you can just fill in this here. Now, we have a full table, and I think with this full table, we can start eliminating some variables and getting some answers. So let's talk about it in the horizontal direction. I think we're going to use this middle one here. So the s, which is equal to s divided by 2, s over 2, is equal to ut. What's u? U cos of alpha. And what's our t? Our t is actually this one here. What we're going to do is multiply it here. And it may look like a really long equation, but what's useful is that the a is 0 in the horizontal direction. So when a is subbed in here, this part just cancels. We don't even need this part of this equation. So here we have an expression for s over 2. I'm going to make s the subject of the equation. I don't want s over 2, so I'm just going to multiply both sides by 2. And here you need to be careful. It's a u by a u. So that's going to be u squared. U cos alpha sine alpha, and that's all over g. So I have some expression for s here. What I'm going to want to do now is, using the vertical components, I'm going to try and find another expression for s, let them equal to each other, and hopefully get some kind of elimination. So which one am I going to use? I'm not going to use this one. I'm going to use the last one for the vertical side. So I'm just going to do it down here. So v squared, v is 0, is equal to u squared. U squared is u sine alpha, so u times u, and sine times sine, so sine squared. And plus 2, the a is minus g, and s we don't know. Now, using a bit of algebra, we can get another expression for this. S is equal to u squared sine alpha over 2g. So this comes over to this side, becomes a minus. This side is minus 2g, dividing minus by minus, we just get a plus. And now we have s is equal to s. Now both of these are equal to each other, so we can eliminate the s's here, just let them equal to each other. So we don't even need to talk about the s's anymore. I'm going to move this over here. Now my work is a bit crooked, but using this, I think this is very good. The equation might still look scary because there's so many variables. We have u, a, and some people might be scared of g, but we need to remember g is a constant. It's 9.8, so we don't even need to worry about g. U squared is on both sides. Since it's on both sides, we can just divide u squared on both sides. So that's gone, that's gone. We don't even have to worry about it anymore. And all we're left with is 2 cos alpha sine alpha over g, and sine alpha over g. That's just sine squared. Now, I'm going to use some simple algebra. The g is going to go over to this. Actually, I'm going to multiply 2g on this side. So here I have 2g times 2. So that's 4g. And cos alpha. And since on this side we have one sine, and on this side we have two sines, sine by sine, I'm going to divide both sides by sine. So this side is going to divide. And here we have two sines, so it's not going to be sine squared anymore, it's just going to be sine. So we know 4g cos alpha is equal to sine alpha. And g divided by g, that just cancels out. And this part you might not know, but it's very useful, and you should always remember it. It's that tan of an angle called alpha is equal to sine of alpha over cos of alpha. So using this, I'm going to, here this is not possible to solve without this identity. What we're going to want to do is we're going to make tan alpha in this equation. So I'm just going to move the cos to this side, it's going to divide, and there we have our new tan. So we know basically that tan of alpha is equal to 4. And when we use tan inverse, so alpha is just equal to tan, and I'm writing very slanted, but alpha should equal around 76 degrees. It's very slanted there, but it was really simple. The last part may have been rushed, but basically I'm going to explain my process from the start. is we filled out our table from what we knew. This, I think the top part is really basic. I don't think there's much to know. Then we found out t in terms of the values we were given. And it's basically just logic. You need to remember that the projectile is symmetrical. So Sy here is just half of the Sx values. And eventually, using this identity, we can figure out that the alpha is equal to 76 degrees.